Assalamualaikum warahmatullahi wabarakatuh. This is group 6 and we will present about the Hartley oscillator. So my name is Nafizani Izzati binti Rosni and I will present about the introduction. So oscillators are electronic circuits that produce a continuous periodic waveform at a precise frequency. It generates the output frequency without the use of the input signal. Oscillators convert a DC input from the supply voltage into an AC output waveform. An oscillator is basically an amplifier with generative feedback or positive feedback. So what is positive feedback? So this is the condition where a fraction of amplifier's output signal is feedback in phase with the input. So basically positive feedback is where the input and the output signal that were given back to input are the same. Okay, so that is a introduction for what is escalator. So we will get into the Hartley escalator now. So the Hartley escalator design used two inductive coils in series with a parallel capacitor to produce a sinusoidal oscillations. The combination forms a resonance tank circuit, or we call it LC circuit. So what is LC circuit? So this is the LC circuit, but this is the basic LC circuit. For Hartley oscillator, they use two L. L is inductor and C is capacitor. So the basic operation for this LC circuit is when there's a voltage drop at the capacitor, it will send a current to the coil, to the L. So when there's a current to the L, there will be energy in it and it will build a magnetic field. So when there's a magnetic field, there's the voltage. So the voltage that will produce in the magnetic field cause a current to recharge the capacitor with the voltage with a different polarity. As you can see here, okay, this is the start positive, negative, send current and build a magnetic field. And when the magnetic field produce a voltage, it will recharge the capacitor with the different polarity. So this process will begin again and again and again. Okay, so it's also called a resonant feedback escalator conversion that makes the circuit turn into self-tuning base escalator circuit. Process in the circuit called automatic base bias. It automatically changes the bias by control the amplifiers in such a way that if the escalations increase in amplitude, the bias is increased and the gain of the amplifier is reduced. So that's all for me. And now we pass it to my group members. Thank you.
Okay, my name is Muhammad Faris bin Azmi. Okay, first I want to explain my part, which is circuit diagram. Okay, first this is the circuit diagram of Hartley oscillator. Okay, first in a Hartley oscillator, the oscillation frequency is determined by a tank circuit. Okay, first I want to explain. This is the tank circuit. Okay. Okay, a tank circuit is comprising of two inductor and one capacitor. Okay, two inductor and one capacitor. The inductor are connected in series and the capacitor is connected across them in parallel. Okay. Next, in the circuit diagram, resistor R1 and R2 give a potential divider bias for the transistor Q1. Okay. Re is the emitter resistor whose job is to provide thermal stability for the transistor.
Assalamualaikum and good morning. My name is Muhammad Syakir bin Syed Alvi. I am from section 2. Ini adalah circuit bagi operation. Bagi operation ini, the Hartley oscillator design use the two inductive coil in a series with a parallel capacitor to form its resonance tank circuit producing sinusoidal oscillation. When the circuit is oscillating, the voltage at point S collector Relative to point Y emitter is a 180 darjah out of the phase with voltage at point Z base relative to point Y. At the frequency of oscillation, the impedance of the collector load to resistive and an increase in base voltage is caused a decrease in collector voltage. Thus, there is a certain of darjah phase change in the voltage between the base and collector, and this along with original certain of darjah phase shift in the feedback loop to provide the correct phase relationship of the positive feedback or for oscillation to be maintained. The amount the feedback depends upon the position of the tapping point of the data. If this is a move near to the collector, the amount of the feedback is increased, but output taken between the collector and earth is reduced and vice versa. The resistor R1 and R2 provide the user stabilizing DC bias for the transistor in the normal manner, while the capacitor acts as DC blocking capacitor. In the Hartley oscillation circuit, the DC collector current flowed through part of the coil, and for this reason, the circuit is said to be series fed with the frequency oscillation of the Hartley oscillator being given as. Okay, itu saja dari saya.
Now I will explain to you all about the important formula for the Hartley oscillator. Okay, the first important formula is the frequency. We want to find the frequency for the Hartley oscillator. Okay, we just need to use the formula 1 divided by 2 pi divided by LT times C. What is LT? LT is the equivalent inductance or total inductance value for this oscillator. How we want to find LT? We need to use L1, which is the value of the first inductance, plus L2, which is the value of the second inductance, and M. M is the mutual inductance for this oscillator. But if mutual inductance doesn't exist, we just need to cancel M and we just use L1 plus L2, and then we will get the value of the LT. And then we times C. C is the value of the capacitor, and then we will get the frequency for the Hartley oscillator. The next formula is the bandwidth. Bandwidth is the gap between the highest frequency and the lowest frequency. How we want to find the highest and lowest frequency? We need to use the first formula, frequency, and then when we get the highest and lowest frequency, we need to subtract them, and then we will get the bandwidth or the gap of the frequency. The last formula is the gain of circuit ratio. This formula is applied when the OPM is act as the active state for the oscillator, and then we need to find the gain of circuit ratio. We use the formula L1 divided by L2, the first inductance value, and divided by the second inductance value. But if the oscillator mutual inductance exists, the formula become L1 plus M divided by L2 plus M. We just add M after the inductance value. Okay, that's all.
Okay, application of the Hartley oscillator. First one is the Hartley oscillator is used as a local oscillator in radio receivers. Radio receiver, also known as a receiver, a wireless, or simply a radio. The Hartley oscillator is a popular oscillator because it has a wide range of frequencies. Second, in radio frequency RF, the oscillator is so suitable for oscillation range up to 30 MHz. Third, the Hartley oscillator is producing sine wave with the desired frequency.